Imagine standing in the shadow of an erupting supervolcano. The air is thick with ash, the ground trembles beneath your feet, and all around you fire and brimstone paint the landscape in shades of orange and red. You might think that such a nightmare scenario could only exist in the pages of a thrilling disaster novel or in the frames of a Hollywood blockbuster. But the truth is far more sobering. In our world, there are ticking time bombs hidden beneath unassuming landscapes, just waiting to unleash chaos upon the unsuspecting populace. These are not just any volcanoes, they are supervolcanoes. And when they erupt, their destructive power dwarfs that of ordinary volcanic eruptions. Even from hundreds of miles away, the consequences can be catastrophic. It's hard to imagine, but the impact of these eruptions is so devastating that it can literally change the course of human history. So what if something goes wrong? What if one of these sleeping giants wakes up unexpectedly and threatens to plunge us into chaos? In this extreme scenario, every second counts. The key to survival lies in predicting the eruption as accurately as possible and providing people with enough time to escape. And here's where the real challenge begins. Unlike regular volcanoes, whose rumblings and tremors can be detected with relative ease, supervolcanoes play hide-and-seek with scientists. They often show no signs of activity for thousands of years, making their eruptions all the more unpredictable and dangerous. But we are not completely defenseless in the face of these natural giants. Scientists have developed advanced methods to detect early signs of unrest among supervolcanoes, giving us a chance to anticipate their wrath. But how do they keep watch over these restless giants? How do they decipher the subtle signals that hint at an impending eruption? And most importantly, what measures are being taken to protect human lives and property? In today's video, we will delve deep into the world of cutting-edge surveillance technology designed to monitor supervolcanoes. We will explore the latest methods used by scientists to track even the slightest signs of volcanic activity, allowing us to predict eruptions with greater accuracy and protect ourselves from their fury. Join us on a journey into the heart of volcanic surveillance and discover how we are one step ahead of these natural wonders. When it comes to monitoring supervolcanoes, we must first understand what makes them so unique and dangerous. Unlike ordinary volcanoes, which typically reach a height of a few hundred to a few thousand meters, supervolcanoes can tower over 2,000 meters above the surrounding terrain. Their colossal size is matched only by the sheer volume of explosive power they possess. A typical supervolcanic eruption releases more than 1,000 cubic kilometers of volcanic material, a number that seems almost unimaginable. To put it into perspective, the famous eruption of Mount Vesuvius, which buried the Roman city of Pompeii, released about 1.5 to 2 cubic kilometers of volcanic material. In contrast, the eruption of Krakatoa in Indonesia in 1883 released about 20 to 30 cubic kilometers of volcanic material. However, a supervolcanic eruption can release more than 1,000 times the amount of volcanic material released by Mount Vesuvius. This immense explosive power can have global consequences. Supervolcanic eruptions inject vast amounts of volcanic ash and gases into the atmosphere, which can block sunlight and disrupt climate patterns around the world. For example, the eruption of Mount Pinatubo in the Philippines in 1991 injected about 2 billion tons of sulfur dioxide into the stratosphere. This led to a global temperature drop of about 0.5 degrees Celsius and significant changes in precipitation patterns. Imagine the impact of an eruption that is hundreds or even thousands of times more powerful. It's clear that predicting supervolcanic eruptions is of paramount importance, and this is where our surveillance systems come into play. The first line of defense in monitoring supervolcanoes is a network of local and regional seismic stations. These stations continuously record the tremors and rumblings of the Earth's crust, providing valuable data for scientists. Any unusual increase in seismic activity could indicate an awakening of a sleeping giant. Sophisticated algorithms analyze the recorded data in real time, flagging any anomalies that may require further investigation. In addition to seismic monitoring, scientists use a technique known as continuous GPS monitoring of volcanoes, or continuous GPS monitoring, which helps to identify even the smallest changes in the shape of the Earth's surface. Specialized GPS receivers are installed around the volcano, which measure the movement of the Earth's crust in 3 dimensions, namely north-south, east-west, and up-down. Even the slightest shift in the Earth's surface can signal magma movement beneath the surface. Magma, being less dense than solid rock, tends to push upward, causing the Earth's surface to bulge. By detecting these changes in altitude, scientists can estimate the rate at which magma accumulates under the volcano. If the rate of magma accumulation exceeds the threshold value, it may indicate that an eruption is imminent. However, GPS monitoring alone cannot determine whether magma actually reaches the Earth's surface. Therefore, to obtain a complete picture, scientists combine GPS data with seismic monitoring results. In particular, they pay attention to a type of seismic waves called Rayleigh waves. These waves are generated by the movement of magma and can travel across the Earth's surface for hundreds of kilometers. By analyzing the speed and amplitude of these waves, scientists can learn more about the properties of the magma and the processes taking place beneath the volcano. To enhance monitoring, scientists also use infrared satellite imagery. Infrared sensors can detect temperature changes on the Earth's surface, even through clouds or darkness. This capability allows for the detection of increased temperatures around a volcano, indicating a possible escalation of volcanic activity. Thermal imaging is particularly useful for monitoring volcanoes at night or in areas with cloud cover, conditions that often make visual observation impossible. In addition to these methods, scientists also use traditional approaches such as visual inspections, gas sampling, and chemical analysis of volcanic gases. By combining the latest technologies with proven methods, experts create a comprehensive system for monitoring supervolcanoes. Despite these advancements, predicting volcanic eruptions remains a complex and challenging task. Volcanoes are highly unpredictable, and even the most sophisticated monitoring systems cannot guarantee 100% accuracy. Nevertheless, the combination of cutting-edge surveillance methods allows scientists to closely monitor potential threats and improve eruption forecasts, providing invaluable time for timely evacuations and reducing the potential impact of these natural disasters. But let's go back to the beginning. What if a supervolcano eruption is detected? What steps are taken to protect people's lives and property? In such a critical situation, timely and efficient action is crucial. First and foremost, an immediate evacuation of the danger zone is ordered. Local authorities activate emergency response plans, alerting the population and organizing the evacuation process. Sirens blare, loudspeakers broadcast official warnings, and mobile phone alert systems send text messages to residents in the affected area. In parallel with the evacuation, scientists intensify monitoring, tracking the movement of the volcanic front and predicting the likely path of the eruption products. They closely monitor seismic activity, gas emissions, and changes in the Earth's crust to refine their forecast. With the help of computer models, scientists simulate various scenarios of volcanic eruptions and calculate the possible consequences. These simulations allow you to determine the extent of the destruction and predict the timing of the eruption. In addition to evacuating the population, authorities take measures to protect infrastructure and the environment. Firefighting teams are on standby to extinguish fires caused by volcanic debris. Medical services are alerted to provide assistance to the victims. Veterinary services take care of the safety of animals in the affected area. Environmental agencies develop strategies to minimize the impact on ecosystems and biodiversity. The international community also plays an important role in assisting countries affected by volcanic eruptions. International organizations such as the Red Cross, Red Crescent, and Doctors Without Borders provide humanitarian aid, medical care, and psychological support to those in need. After the eruption, extensive cleanup and restoration work is carried out. The priority is the removal of volcanic debris and the restoration of vital infrastructure, energy, water supply, and transportation. The affected areas are surveyed to assess the damage and develop recovery plans. Psychological and social assistance is provided to the victims to help them cope with the consequences of the tragedy. In conclusion, the threat posed by supervolcanoes is a serious challenge for humanity. However, thanks to advances in science and technology, we have the tools to monitor and predict their activity, as well as to minimize the consequences of potential eruptions. Continuous seismic monitoring, GPS monitoring of volcanoes, and infrared satellite imagery allow scientists to track the slightest signs of volcanic unrest and provide timely warnings. In the event of an eruption, a well-coordinated system of actions involving local authorities, rescue services, the scientific community, and the international community is activated. It includes the evacuation of the population, the implementation of protective measures, and the subsequent restoration of the affected territories. The memory of past tragedies serves as a reminder of the destructive power of nature and a call to continually improve monitoring systems and preparedness measures. Only through joint efforts can we hope to be one step ahead of these formidable giants and ensure the safety of our planet and its inhabitants.